Welcome to EMR Physics. I am Raju, NCERT 12th Physics. We are solving the numerical problems given in Chapter 6, Electromagnetic Induction. In this video, we are going to see how to solve the numerical problem 6.6. The problem is a horizontal straight wire 10 meter long extending from east to west is falling with a speed of 5.0 meter per second at right angles to the horizontal component of Earth's magnetic field 0.3 into 10 to the power minus 4 Weber per meter square. A. What is the instantaneous value of the EMF induced in the wire? B. What is the direction of the EMF? C. Which end of the wire is at the higher electric potential? This is a given problem. In this problem, length of the wire is given, speed is given, and magnetic field is given. What is asked? We have to find what is the value of the induced EMF. Next, we have to find what is the direction of the induced EMF, and last, we have to find which end of the wire is at the higher electric potential. Let us see how to solve this problem. In the first case, we have to find what is the induced EMF. Let this is a long straight wire which is 10 meter in length. The wire is extending from east to west. This is a horizontal component of Earth's magnetic field. This is North Pole, this is the South Pole. The wire is falling with a speed of 5.0 meter per second in such a way that it is falling right angles to the magnetic field. That is, let this is the long straight wire and this is the direction of the magnetic field. The wire is falling vertically downwards so that the wire is falling at right angles to the magnetic field. Since the wire is in motion, the induced EMF is motional EMF. Motional EMF is given by epsilon is equal to BLV. Here B is the magnetic field, L is the length of the wire, and V is the speed. B is given as B is equal to 0.3 into 10 to the power minus 4 Weber per meter square. Length of the wire is 10 meter. Speed is given as V is equal to 5.0 meter per second. So all the values are known. If we substitute, we will get induced EMF is equal to 0.3 into 10 to the power minus 4 into 10 into 5.0. 0.3 into 10 is 3. 3 into 5 is 15. Therefore, this is equal to 15 into 10 to the power minus 4. This is a induced EMF. Unit of induced EMF is volt. This can also be written as 1.5 into 10 to the power minus 3 volt. Now let us see what is the direction of the induced EMF. In the second case, we have to find the direction of the induced EMF. The direction of the induced EMF can be determined by using Fleming's right hand rule. So according to this rule, we have to stretch the thumb, forefinger and middle finger perpendicular to each other. If thumb represents the direction of motion and forefinger represents the direction of magnetic field, the direction of the induced EMF will be given by the middle finger. We can find the direction of the induced EMF using the Fleming's right hand rule. That is, we have to stretch our forefinger, thumb and middle finger perpendicular to each other like this. If the thumb represents the direction of motion and the forefinger represents the direction of the magnetic field, then the direction of the induced EMF is given by the middle finger. Now the thumb is in the upward direction, but actually the direction of motion is downwards. So we have to rotate the fingers like this. Now the thumb represents the direction of motion because the conductor is moving in the downward direction. This forefinger represents the direction of the magnetic field. The middle finger will give the direction of the induced EMF. So it is pointing from west to east. So by using this, we can find that direction of the induced EMF is from west to east. This is the answer for the second case. Now let us see what is the third case. In the third case, we have to find which end of the wire is at a higher potential. Already we have seen that the induced EMF is from west to east. Since there is a EMF in the wire can be considered as a battery. In a battery, EMF will be from negative terminal to positive terminal. That is, west will act like a negative terminal and east will act like a positive terminal. The positive terminal will be the higher potential. Therefore, east end of the wire is at higher potential. This is the answer for the given problem. If you find this video is useful, please subscribe the channel, share it to your friends. Thank you for watching this video.